The photoelectric effect. The photoelectric effect was described by Albert Einstein. In the PowerPoint, it shows this long definition of what the photoelectric effect really is. But I think the best way to really demonstrate what it is to show by a demonstration. So let's say we have some light here. It's a nice red light. And it's coming down, bang. It strikes our metal surface here. So all this is metal. Metal, 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 metal. When this light hits the metal surface, one electron, as a result, is ejected. Boom, goes away. That's just the most simple version of it. Now let's look at our next one. So say if we have the same light hitting it, the same intensity, same frequency, right? Same result would occur. If we have one photon, it elects for every one photon of the light that's hitting the metal surface, one electron is ejected. Okay? So in this one, what if we were to increase the amount of light? So increase more light on this surface, on this metal surface. What would happen? Well, since now we have more light hitting the surface, more electrons will be ejected. So now we'll have this one being ejected and this one being ejected. Okay? Well, let's look at our last example here. What if we were to change the light that we were using? What if we were to increase its frequency? So it'd be looking more like this. Not the most beautiful thing in the world, but you kind of get the point. It's a lot, has a higher frequency. So since it has a higher frequency, only one electron is going to be ejected, but that one electron is going to be ejected really, really, really quickly. That's kind of the basic gist of the photoelectric effect. So if you just have your basic light beam, say you're just standard one, right? This one all the way over number 1 here. For every one photon of this beam of the electron here, one electron will be ejected. If we increase the amount of light, more electrons will be ejected. If we increase the frequency of that light, the electron will be ejected faster. Simple enough. In addition to this, if we have something of really low frequency light, it would kind of look like, let me kind of draw it out here. It would look like this. It'd be traveling really slowly, very slowly. If we have something that is, very low frequency, no electrons will be ejected. No electrons ejected. Something of really extremely high frequency. By having something of really high frequency light, that's not saying that more electrons are going to be ejected. That's just saying that if you have something if the light itself has a higher frequency, that's just saying that the electrons will just be ejected a lot faster. The only way to increase the amount of electrons that are ejected is to increase the amount of light itself. And that's kind of the basis of the photoelectric effect. So if you increase the amount of light that you're shining on a metal surface, you're going to get more electrons. If you increase the frequency, the electrons are going to be ejected faster. And if you have something of low frequency, no electrons will be ejected at all. That's kind of the basis of it. Have a great day. This is Christopher Zuthan signing out from ChemBuddy.